These two, which ones do we want to see? Go over, have questions about?
Yeah, 2.
2.
Yeah.
Alright, so number 2 is a little weird. It's also something we kind of talked about, but not at the same time. So, domain of this, we're looking left to right. So we know this has arrows, so to the left it keeps going forever and ever towards negative infinity. After this part, it keeps going to the right forever and ever. So it would be negative infinity to positive infinity, but there's this hole right here.
Is that negative 9?
Looking for your domain. It would be everything starting at negative infinity. It would go until you got to this point, so I think this is counting by 2s. So 6. But because of the hole, it's not included, so use a parenthesis, and then we're going to use this weird notation. This means it stops at 6, but then it keeps going. So, and the rest.
Oh, do we have to worry about that symbol now?
No.
Okay.
Not in this class.
Oh, thank God.
Moving forward in your next class, math class, then yes. So this would be our domain. Starting from negative infinity, going to 6, and then keep going. It's basically everything except at 6. Questions about that? If you do not have your graphing calculator, go grab it. Second plus 712. I'll redo it. Second plus 712.
Huh? What is second plus 712?
Correct. That's just how I would advise that you also do this. So today's lesson is going to be on parent functions, just a couple of them. There are more than what we're going to talk about today. We're not talking about any of the other ones. You'll learn that in your next math class. And transformations and how they work and describing them and all those type of things. So before we do anything, we're going to graph this on this. So let's put in x squared into your calculator into y equals. And then you can go into your table to start finding values. Just like what we were doing before, find where your y values repeat and then find the middle. So 0, 0 would be our middle. And then we have negative 1, 1, 1, 1, plot those points. Negative 2, 4, and 2, 4, plot those points. I don't know what the heck is. So this is what's called one of your parent functions. If nothing changes, if we don't do anything to it, it's always going to look like this. So when we talk about our transformations, we're going to talk about what happened in comparison to this one. So we're going to start with this first one. We're going to put the plus 2 at the end of our calculator, or at the end of our equation. And then you're going to graph. Compared to the original, what happened?
It moves up 2.
It moved up 2, yes. Also one thing. that would be the physical change that we saw happen. The specific rule, and the rules are what we'll actually need to remember. The change helps you see what happened. This is a vertical shift up by 2, or up. So when we write our rules, we have to say, is it horizontal, is it vertical, what type of transformation is happening, so in this case the shift, what direction, and by how much. So if this one moves up, what do we think this one's going to do? Yes. So I'm going to graph it just so you see it. But it did indeed move down 2. So then that would be the opposite, vertical shift down 2. So make sure you're writing this down. Then we can put this next one into the calculator and see what happens then. Yeah. So compared to the original, what did this one do? So this is like when we were doing the vertex and finding the vertex. Everything on the inside did the opposite of what we thought it was going to do. So it says plus, so you think it's going to move to the right, but it does the opposite and moves to the left. So that would then be a horizontal shift, left 2. So then the next one most likely is going to do what? Yeah. So I'm going to graph it just so you see it. But it did move to the right. So then that would be the opposite, horizontal shift. Right 2. When you're ready, go ahead and put the next one in your calculator, 2x squared, and see what happens. It does kind of look the same, but there is a slight difference. So if I go into my table, second graph, the y values are different. So it still starts at 0, 0, but instead of negative 1, 1, it's now at negative 1, 2. Instead of negative 2, 4, it's at negative 2, 8. So it's like all your y values were multiplied by 2. And if we look back at the graph, it's kind of narrower than it was before. I'm going to say it's narrower. And that rule would be a vertical stretch by 2, or by a factor of 2. So the stretch, you can think about it like it's stretching towards the y-axis. So as it's doing that, it's getting narrower. So you can probably assume what the next one will do, but go ahead and graph that. What does that one do? It gets wider. And if you wanted to compare the y values, you could see that it does that. So that would be a vertical compression. By what factor? 1/2. Okay, and then go ahead and put the next one in. What happened with that one? Yeah, it flipped upside down. So that would be a vertical reflection. So before we start to mix them, that's what the last three are. What questions do we have so far?
Wait, do we have to memorize like the f of x? Or what exactly do we have to memorize?
So we haven't gotten to the actual things, but you will need to be able to recognize the rules. So I was about to say before we started this, as we start doing these, you can still graph them, but the goal is to move away from the graphs and notice either from your previous examples or just by looking at the function itself, seeing what rules or what changes took place.
Oh.
So right now you can still practice using either the graph or looking at your previous examples. For this next one, I'm not going to graph it. You guys can, but again, try to come away from graphing it. Find what took place, what changed. It flipped upside down.
Down to the left.
And then it also moved left, yes. All right, both. So it did flip upside down because of the negative, and then it moved left 1 because of the plus 1 inside. Then how would we write those two rules?
Vertical reflection. And horizontal shift.
Horizontal shift by
1.
in what direction? Left. What's nice about this is whatever you write, you can always graph it and double check. Did I get these right? Horizontal shift. I didn't write out horizontal. Look at the next one. See if you can figure out what changed, what happened. Julia? Okay, and Tasha, say again. It did do that.
Let's back those up.
Yeah, so we don't have to say that it flipped back up because we're always comparing it to the original. That's always up. Trying to tell us so we remember what this was. So then what would those two rules be? By what? Vertical stretch, not by 2. By 3. So whatever number is multiplied. And then the other one?
shift. Can we push it down 3?
Down 2, but yes. What time did your pass say? Then look at the next one. Find what changed. So yeah, it does do that. So it does also do that. Say that again, Francis. You can just say them out loud. Sorry, if you said something I didn't hear. Not narrower, gonna flip. It is gonna flip. Have a good rest of your weekend. We are missing one thing.
What?
Dash line, yes. So the negative tells us it flipped, the 1/3 tells us it got wider, the -3 tells us it moved to the right, and the +1 it moved up 1. So then how would we write those rules? We don't have to go in order, just tell me which one you're going for. Right 3. It's vertical. We haven't talked about horizontal yet. And the last one. Just 1/3. Before we do some more examples, what questions do we have on any of these?
Nothing yet. I just have a headache.
Yeah. It is a
This
lot.
is too much. This is too much.
It's a lot. Precious. Not soon. In April. Yes, Joey.
We can't use. Oh.
No, that's not what she said. She said, is there a section you can't use a calculator? There's not a section you cannot use a calculator.
Okay, thank God.
You'll have your calculator.
Oh, thank God.
Right, go on to the back once you've written all that down. What's also nice is this won't be the first time you see these, so it'll get repetitive, you'll remember them, it'll make more sense, all those things. It's just a lot right now because have you heard these words before?
No.
Maybe, maybe not. It's a lot.
I've heard compression, but other things.
So this is another one of your parent functions. There are many, I don't remember how many, but we're only learning 2, quadratics, absolute value. So we're going to graph this one. So in your y equals, if you hit alpha window, a menu should pop up. You're using the first one, ABS. And then you can put an X in between. Alpha window, ABS, put an X in between. And then I'm going to look at the table to find values. what's nice about the absolute value is it works just like the quadratic. Find values that repeat and find the middle. So 0, 0 would be our middle. And then we have negative 1, 1, 1, 1, negative 2, 2, 2, 2, negative 3, 3, and 3, 3, and it's just going to keep repeating like that. So negative 4, 4, 4, 4, negative 5, 5, 5, 5, negative 6, 6, 6, 6. So this would be our parent function, absolute value parent function, if nothing happens to it, if it doesn't change at all. It's always going to look like this. So we're going to compare whatever to this. What's also nice about transformations is that whatever you learned before is going to be the same, just a different function. So you can put the plus 2 at the end of your equation, but it's going to do the exact same thing it did for the quadratic, which is what?
Is this what's that called? Vertical shift up.
Two. So that's the rule. What did it actually do? So then for each of these, you can graph them if you want to see what it looks like. You can look at your previous notes. What would this next one be?
Move down to.
Move down to. And the rule would be? Down to. So then your next one, you can either graph or look back at the back of your notes to figure out what that one would do. It would move left. So that rule would be shift left 2. Not this particular, later when we're still doing this, but in a different sense, then yes, but not this objective. Okay. The next one? Right. Right. And the rule? Yes. The next one, graph or look back at your notes. It does get narrower. And that rule? Vertical stretch by 2 or by a factor of 2, either or doesn't matter. So then the next one? Wider. And that rule? And then do the next one, either graph or look at your notes.
flips upside down?
Yes. And that rule? Now, you can probably guess what this next one is, but I want to show you what it would look like. So I'm going to have the original graph as well as that new one. So it may be a little hard to see, but there's blue and then there's red drawn on top of it. So the blue is the original, the red is the negative version of it. What happened is the change, it doesn't really look like it changed at all, but it went like this. It horizontally reflected. But you won't be able to see that unless it moves. Correct, also that. So you'd be able to do this, but just change the thickness of the line. That's why I wanted to show you. What was your question?
Oh no, it's stretching.
So this would be, the change is really none. But it did horizontally reflect. So horizontal reflections are a little tricky, and we're going to do another example with that. Questions so far before we try some of the next ones? Did you have a question? Okay. All right. Try this next one. Graph or look at your previous notes. Did it move down? Moved up? What would the other one be? The 0.25, what would that do? Wider, not narrower. Because the 0.25 would be like if we had a 1/4 out there. So then, what would those two rules be? Not horizontal compression, but still vertical. So horizontal right now is just reflection and shift. We'll talk about the other ones later. But vertical compression. You can either say 0.25 or 1/4, either or doesn't matter. And the other? What direction? By how much? 0.25, yes. Look at the next one. Try that one.
Wouldn't that move down?
Not down. It does move, but not down. Doesn't do that. Not for this one. What'd you say? Doesn't up. It flips down, but it doesn't move down.
Yeah, it flips down and
it
moves
flips
to the
down
right.
and does move to the right. Yes. So we have to be very specific with our wording. You can't say it moved down because that would be a shift, but it did flip down. Yes. So then how would we write those two rules? Just vertical reflection. You don't have to say the actual thing. It's like implied. And then the other one? What direction? By how much? Yes. And then the next one, find what changed. Did it move up? Move down. By how many? Okay. What else? Not in this case. It does get narrower. And one more thing.
It's
Left. Always opposite. So then our rules would be what? One. Narrower would be what? Vertical stretch by not really. By 5, yeah. And the last one. 5 and what direction? Questions on those? We're just going to do a couple more examples. So we talked about the different reflections, but I want you to actually see it. So in this first example, it tells us, we started at the original, the parent function, it moved to the right 2, and then we added in the negative, so I'm going to show you what happens there. I'm going to draw all 3 so you can see the comparison. We have the original. Alright, so I'm going to draw the original when it moves to the right and then when it reflected. So the blue is the original, red is when it moved to the right, and then the black is it moved to the right and reflected.
do you have to read out the rules for all 3 of those?
Just the 2. Reflected and moved to the right. So we can do that really fast. It told us already that it moved to the right. And we saw that it flipped. So that would be our horizontal shift, right 2, and vertical reflection. Then I'm going to show you what happens with this other one. I'm going to keep the first 2, but change my negative to be on the inside.
They're all
Yeah. So
different positioning.
if you didn't know what we put in, what would you say this black one did compared to the original? Yeah. So if you didn't know any better, you would say this moved to the left instead of just what it actually did. So it actually moved to the right, like it was the red, and then flipped over and became the black. So the only time we really see horizontal reflections is if it moves. So I'm going to write in what it looked like it did, but also what it actually did. And then try to questions, I'll answer your questions. So this one to start is what it looked like it did. But then it actually moved to the right tube. And the change doesn't look like it did anything but, I'm sorry, it would have to be horizontally reflected. So how you want to say that is if you flip over the y-axis, flip to the other side, something like that. So then the move, I didn't mean to start this one. The move right to would just be the horizontal shift right to. And then your other one would be a horizontal reflection. So horizontal reflections are weird because they look like other things. They look like other things happen. Really, you just need to know if you see it in a problem, what it did. If you can recognize that there's a negative on the inside here, so there would be a horizontal reflection, that's all you need.
Does that say flipped order?
Flipped over. What's also weird about these, because of the way it looks, it could be written different ways. And they would all graph the same, like on top of the other. So it's weird. Precious, what was your question? What were you confused about?
I was confused about reading it and how you know that it flips over.
You have to know that there's a reflection out there, there's a negative out there, and that would be a reflection. So we haven't done this yet, but next class I'm going to show you how you can see it just from the equation, be able to picture it without graphing, and shortcuts for that. So we haven't gotten that part yet. Okay. Any other questions? So, as I mentioned earlier, there aren't any Khan Academy quizzes on this, but there are the two that are due next week on what we did last class. If you did want practice on this, there is a Delta Math. It is really just parent functions and different parent functions and how they move and things like that. So you could do that. If you need to finish a test, now would be a good time to do that. If you need to work on retake work, you can also be doing that. So use this time wisely in whatever you are working on. Let me know if you have questions.